All right, so I'm recording this on Echo 360 today, so my computer is really slow. So my apologies if that causes a lag. Hopefully it won't be too bad. Okay, so first I just wanted to go over the schedule for the rest of the semester. I looked at Canvas today, and I think this is all up to date, but just to give you some insight on what to plan for. So this week, we're in week 14 right now. So for lecture this week, there's a series of videos on the eastern forest in the eastern United States. So watch those videos. There's no quiz with those videos, which is probably a mistake on my part, but there's no quiz this week, but our assignment next week will be building on those videos. So we're going to do some calculations in class next week using the Forest Inventory and Analysis Network. Is that what the A is in FIA? Yeah, thank you. I just always say FIA. So make sure to watch those so you're prepared for that data next week and what we're going to discuss and some of the questions we're going to answer next week as part of that assignment. In lab this week, we're going to go over assignment 12 and collect all that data and try to get that in order a little bit so that you can create some figures or at least have those figures started before you leave class today, because that is going to be due next week. So next week, we're actually pretty much done with lecture material this week. So Eastern Forest is really the last ones we're going to do. So next week there is no lecture to watch or any quiz, but you have a little extra time to work on your decomposition report that is due next week. In lab, as I kind of already mentioned, we'll be analyzing some data and answering some questions on the structure of eastern forest. I want to say eastern deciduous, but they're not all deciduous. So that's week 15 and week 16. Your third exam is due that week. So there's, again, no lecture material, but your exam is due by Friday at, I think I made it 11:59 p.m. I'm pretty sure. You can double check that. But that will be due on May 8th. And then after that, we're done. So typically, and I've talked about this earlier, that we had a poster that we were going to do as our final project. And because the semester kind of got started late with material and stuff, I just felt like I'm not going to cram it in at the end of the semester. So we are winding down in this class. And so at the end of week 16, we'll be done and we won't have to stick around till, I think our final was Thursday, afternoon or something. So now maybe some of you can get out of town a little earlier than you were going to. So that's what we have coming up. The one thing that is due finals week, if you want, there's an extra credit opportunity. And so let's look at that briefly right now. So let me go to student view. So I put this under week 14. I don't know if it's the best place to put it, but it is. I just made it due on May 13th. But if you look under the week 14 module at the very bottom, there's this symposium extra credit opportunity, and it's worth, I think it's 15 points. I actually didn't put it in there because sometimes I adjust it. I try to make it proportional to the class, the total amount of points we have in the class, but it's usually between 12 and 15 points. So what you have to do is watch a seminar and then just write some stuff about it. So there's some information here about what you need to write. I want they don't have to be super long paragraphs. But your first paragraph should summarize the talk or seminar that in here I have it attended, but we've recorded all of our seminars this last semester in our department, and so you can just go and watch one of those. There's a couple more left this semester. If you want to attend one in person, let me know, and I can point you in the direction of some of those seminars. But you need to just summarize that seminar and what the individual talking what did they talk about? What did they tell you? And then the second paragraph is describing your thoughts on the seminar, and it goes into a little more detail, but really you just want to relate that to your interests. What are you interested in? What did that person say that somehow connected with you or made you think about something that you might utilize in the future? So 2 short paragraphs. Turn that in. There's a place on Canvas to submit that. Again, that's due by finals week, Friday finals week at 5 p.m. There is a link down here in this assignment description that will take you to our departmental YouTube page. And there's a playlist for the spring 2022 seminar series. So click on that playlist and there's I don't know, maybe 8 or 9 seminars in there and you can watch any of those, okay? So again, that's due finals week, an extra credit opportunity if you would like it. All right, any questions? Yeah.
What's assignment 13 that's due this Sunday?
I think that was the Eastern Forests one. Let's look at that real quick. And if so, that'll be due next week.
It's listed as a graded, forest structure in the eastern wall.
Yeah, okay. I did not update that due date. Let's do that now.
You've got due the 24th. Oh.
So that one will be due. Let's not do it at 5 a.m. And then you should be able to view it. All right, so that should be due a week later. We should be able to get most of that assignment done in lab, but sometimes there's a few questions you still have to answer, so you have a few extra days to finish that up. Other questions? Yeah.
It said no lab the week of the 3rd, right? And that's what...
The poster is not due anymore.
Oh, it's not.
Yeah.
Okay, it's still on there, so I was wondering.
Yeah, I haven't updated everything, I guess. I was hemming and hawing about it till like 30 minutes before class. So I haven't taken it off, but I'll take that off. So, all right. Any other questions? Okay. So let's get busy talking about the decomposition data and then get working on that. So, will you hand those out?
We have your final leads up here as well.
So, assignment, so this is assignment 12, and on Canvas up till just a little bit ago, I just had the first, kind of the methods part of this assignment posted. I've now added the report section to that Canvas page, but this is what it is. So I'm giving you the handout of it, but if you need to reference information about what you need to include in the report, it's now posted on Canvas. All right? So let's talk through what needs to go into this report, and then we can go ahead and weigh our last leaves and take care of that stuff. Okay. All right. I know it's exciting that I just canceled the whole assignment, but let's simmer down. Okay. So in your report, you all know the routine now. There's going to be an introduction section. At the end of your introduction section, you're going to have some hypotheses. There's a reminder in there of the format that you need to state those hypotheses. There's going to be a materials and methods section. I didn't give you any information on that because you've done that a few times now. We'll come back, we'll come back and talk about results in just a second. And then the discussion section, I didn't specifically request literature, but that's certainly always a good idea to include in your discussion some, reference to information that's been collected in the real world, so to speak, out in the field, and how our results might relate to some research other folks have done. So no specific requirement, but I highly recommend you do that. And you're now experienced enough to know you should just do that. So let's talk about results briefly. In the results section, you need to provide 2 figures and 1 table. So All right. So we have looked at a figure like this a few times. And this is ultimately the data we're trying to get from this assignment is this relationship between time, the time your leaves were in the soil, and the percent mass remaining of those leaves. And remember, we've got 3 leaves, and so each time, each subsequent measurement we make, that leaf has been in the soil longer, so hopefully more or less mass is remaining because more was decomposed. So hopefully we have some relationship, some negative relationship there. Also remember, if this is time 0, we get a freebie, because at time 0 we know there was 100% mass remaining. So assuming you were able to find all 4 leaves and get weights for them, you should have 4 data points in your figure. All right? So we are going to then calculate the rate that mass is lost over time. And so we're gonna fit a line essentially through that data. And that is gonna be, it's referred to as a decay coefficient. And that's because we stole it from chemistry. And they call it a decay coefficient. But what this really is our decomposition rate. All right, so the negative slope of that line is our decomposition rate. So hopefully all of your values, once you calculate that decomposition rate, should be a negative value because we've got a negative slope. And so the steeper that slope or the more negative the value, it means the faster that mass was lost. So the decomposition rate was faster. So the more negative your number, the faster that decomposition rate. And the less negative, the slower that decomposition rate. All right? So one of the things you need to do today is after you weigh your leaf is you need to calculate that decay coefficient for your treatment and the species you were given. All right, that's one thing we have to do today. So let's, I'll leave that up there for now. And let me get a different color marker. So for figure 1, you need to present 2 sets of data, okay? One set of data is going to be your data for whatever species you've got in whatever environmental conditions you have or you did have. That's what you're going to present on here. For figure 1, I need to see a sheet because I got to remind myself which one is figure 1 and figure 2. Okay, so for figure 1, you're going to find another group that had the same species as you but different soil conditions. All right, and it can be different temperature but same moisture, different moisture but same temperature, or different temperature and moisture. I don't care what it is, but they have to have different soil conditions than what you did in your experiment. Okay, so in figure 1, you're going to have 2 sets of data. That one should really be right on top of it, but like that. And so the black symbols in this case are your data, and the blue symbols are some other group's data. So if we've got the same species but different environmental conditions, what are we kind of testing by comparing these 2 data sets? We're testing the impact of what on decomposition rate? Temperature or moisture, right? Environmental conditions. Not litter quality, because we have the same species, right? So we're going to assume litter quality is the same. But this is going to test how important environmental conditions are in controlling the decomposition rate. All right? So that's figure 1. Figure 2 then is going to be almost the same. You're going to have time, you're going to have percent mass remaining, you're going to have your data. And then the other data you're going to compare is the same environmental conditions but different species. So I should probably have a third color. I don't know if I have a third color on me. John, you hold it. All right, so you're going to have 2 different treatments or sets of data on your second figure, but this is just going to be testing differences in litter quality because the environmental conditions were pretty similar between them. All right? So that's what figure 1 and figure 2 are going to include. So in this case, which set of data exhibited the fastest decomposition rate? The black symbols or the red symbols? Black symbols, right? So that would have a steeper negative slope than the red line. So there's red line, there's black line, all right? So in this case, do we think the red data represents a higher litter quality or lower litter quality?
Lower.
Lower litter quality. Boy, that's harder to say than I thought it would be. This is lower litter quality because it decomposes more slowly. So there's something about the chemistry probably of these leaves that makes it harder for those microbes to break down those particular litter or leaves. In this case, then, our blue symbols represent faster decomposition rates compared to that black line. So which one of these would you say probably had, we don't know because I'm just making this up, right? But which one of those is probably warmer temperature, the blue symbols or the black symbols?
Blue.
Probably the blue symbols, right? Warmer temperatures typically speeds up decomposition. It helps those microbes work a little bit faster. Assuming what? Assuming the microbes have what?
Moisture.
Moisture, right? If they don't have moisture, then that might actually slow decomposition down. So to actually interpret some of this information, you're going to need some information on the soil moisture and the soil temperature of the group's data that you're going to get and compare your data to, okay? So when you get data from another group, you're going to get the percent mass remaining of each of their 3 leaves along with their average relative water content of their soil and their average temperature of their soil. All right, and with that information, then you'll be able to do a pretty good job of interpreting what's happening in that figure. All right. Okay, so those are the 2 figures that you have to present, and in each of these figures, you're presenting, all of your leaves, the data from each of your leaves, along with our freebie there with that times 0. In your table, you're not going to present all of this kind of, I'm going to call this raw data. We're not going to present all of this. All that you're going to present in table 1 is that K value, or that's the main thing you're going to present in table 1. So in table 1, I did not give you like a format for this, so you can kind of format it however you want, but you might have something like this. Let's see. Let me look at my sheet again. Treatment, and then we're going to have the average relative water content of the soil, average soil temperature, and then your K value. All right, I didn't need this. So, make sure that's all we need to present. I think that's all you need to present in table 1. So, what species did you guys have?
Aspen.
You had aspen. All right. We had some spruce in here, is that right? Yeah. And we had pondo pine? Yeah. Anything else? Nothing else in here? Okay, we're gonna have one more species from Thursday, which is a grass species. What did we do? Elemus?
Yep.
Yeah. So we'll give you all the scientific names here so you can put the scientific names in. All right, so let's try to make this somewhat of a pretty table. So we've got 4 species, but then we've got 4 treatments for each species, right? So we have 70 lowercase t, 70 capital T, 30 lowercase t, and 30 capital T, right? So then we would divide all of these into 4 lines. This is going to get messy. That's all I'm going to do. And then we would have our average relative water content for this species and this treatment here, and our average soil temperature, and then what that K value is. The main point I want to make here is that if, I can't remember, I think we have some, like multiple groups have the same species and same treatment, okay? If that's the case, I don't want to see two records for aspen that's 70 lowercase t. You're going to average those together, okay? So if there's multiple records, so let's say, tell me again what you had aspen, which treatment?
Top one.
So they had this treatment combination, all right? So in a second, we're all gonna, not in a second, it's gonna take us a little while, but we're all gonna enter our data into a Google Sheet. If you see two rows in that Google Sheet that both are aspen at 70 lowercase t, average the K values, the soil temperature, and the relative water content together and only present one value, all right? Because we have some replicates, which helps us get higher quality data. All right? So make sure you're averaging each species and treatment so you're not reporting them. But then give us the average relative water content, soil temperature, and K for each one. Then we can look at this data, especially this K data, and see what's interesting about it. Are we seeing differences between these species? We should, because we've got some low quality species here and some pretty high quality litter quality with these two species here. And I'll tell you, the grass, they could, at time point 1, they could barely find the grass. Like, so I don't even know if they'll get 3 data points because it was decomposing so fast. So we should see a really different rate of decomposition in the grass compared to even the aspen. And we'll see, what did the aspen look like? Was it like pretty decomposed?
Not as much as I expected.
Okay. All right. Yeah, based on the second sampling, I thought it would be more skeletal, and it seemed like there was still a decent amount of material there. So we'll see what it looks like. But we'll kind of look at this data and make some interpretations about that data. Remember, our main goals are to think about litter quality, soil moisture, and soil temperature, and how those different things impact decomposition rate. All right? So that's what you're going to want to talk about in the discussion. So what I'd like to do is go ahead and weigh your last leaf. Make sure you have percent mass remaining calculated for all your leaves. And then you're going to calculate the decay coefficient. And I'll let you weigh your leaves and get some of that done. And then I'll go over that in Excel and how you can calculate the decay coefficient. Then once you have all of that data, then you can start entering it into the Google Sheet that's provided. That is also under week 14, I believe. What week am I under? Let's go to week 14. So the second to last entry on week 14 is your class decomposition data. If you click on that, then there's a link to that Google Sheet where you can enter your group's data. Let's just look at that briefly. So that's what that sheet looks like. Very exciting, huh?
Might need access, Troy.
If the link should give you access.
Okay, I'm requesting access now.
Oh, don't request access. I'll just make it public. I don't want to respond to everybody. So I'll just make it public here in a second.
Yeah, it was that first Google Sheet that let me learn how you can mute Google notifications on Slack.
Oh, yeah, right. So I can't, right now it's not behaving and I'm not going to waste or spend our time on this, but just make sure you enter each group member name here. I don't think we have groups with more than 3. Then you're going to put your species that you had, the treatment temperature. So that's either going to be a lowercase t or capital T. Make sure after you move off of this cell, it stays the right way, because if you put lowercase, it might try to make it capital. So make sure you have the right treatment there for temperature. Put in for soil moisture treatment, put in either 70 or 30, whatever your treatment was. This is going to be where you're going to put your decay rates or your decomposition rate. And then this is the average soil temperature. So take the soil temperature reading from all of the weeks that you have data for, average that together, and put that one value in here. And your average relative water content of your soil is that relative water content before you added water. All right? So that shouldn't just be the same as your treatment value. That should be some value lower than your treatment value. All right? So average all of those numbers and put that there. Okay? And I'll just make sure to make that public in a second. Any other questions before we get going? Okay, your leaves are up here, so go ahead and weigh those. Get your percent mass remaining calculated. You could go ahead and calculate your average soil temperature and relative water content, and then we'll talk about how to get your decay coefficient. Does anybody need a laptop? There's supposed to be a laptop cart here. Okay, I'll make sure to, I'll go get that. Do you mind, going and asking if they can bring that up?
Is it just the
Go just knock on Randy's door, or you could even go downstairs to the computer lab, because they're the ones that usually bring it up, and just say like, hey, we got one scheduled, can you run it up? Yeah, thanks.
If I had a job opportunity, the job opportunity that's okay.
Oh, I didn't have it set. Will somebody click on that Google Sheet link and tell me if it works?
That works.
Okay, thank you. You can't edit it? Right now it's only for view. All right, now I think you should be able to do it. Will you let me know when you have your third leaf? I'm going to use some of your data for this. Oh, okay. Will you give me, let's see, I guess we can do this one. Will you give me your first leaf, both the time and percent mass remaining? Oh, perfect. Thank you. Do you have percent mass remaining calculated yet?
Yeah.
Where am I looking? Oh, I see at the bottom, right where the table says. Thank you. Oh, we do one other thing first.
Yeah.
Calculate time in days that each of these were in.
Yeah, no problem.
Yeah.
laptops are on their way?
Okay, thank you. I just did it this morning, so they might not have had it on their radar.
Yeah, I think it was also a matter of, it's one already? Oh, okay.
Gotcha. Oh, crap. All right, fair enough.
They may also be, I think, potentially a little short-staffed because there's normally like the head IT guy was manning the desk at the computer.
Oh, really? Oh my gosh, yeah. They must be short-staffed.
So I think finals
poor
week,
Randy.
I think finals week is hitting their staffing.
Gotcha.
I'm so excited you're going to be at Cambridge.
Yeah? You going for a session?
I am. I know.
Yeah. It's usually okay. Last time, like, we went up to the Alpine hiking in the snow.
There's a lot of snow.
Yeah.
Cool.
Thanks, Randy.
Yeah.
You're manning the desk downstairs today?
The person called in sick and I'm doing a bad job of it.
Sorry.
Like, I was looking at the clock, it's like, I knew I had to, because I had to put the thing on the schedule, and then I'm like, oh, yeah, it's fine, okay. No worries at all. All right, there you go. Yeah, Jack thinks so.
Thank you.
That's why they call them. Yeah. Because they realize that it's
Okay. And you had Aspen 70 lowercase t. All right. Thanks. I'm just curious.
You're this good, all right.
You guys had ponderous pine,
Yep.
is that right?
Yep.
What were your environmental conditions?
Air temperature, room temperature, and stuff.
Oh, okay. Perfect. Let me know when you get that. I'm going to use your data for
Okay.
example.
No clue, but honestly, I haven't checked.
For the x-axis in this figure, the time is in number of days. So you need to calculate, you need to convert your dates to number of days that that leaf was in the soil. And make sure that the length of time it was in the soil, you take the date that you extracted the leaf from the pot, not the date you weighed it. Right? Because it's always the date you weighed it is a week after you took it out of the pot. So just make sure you have that aligned correctly. But calculate that as well. Number of days each leaf was in the soil.
What's the do you need me to find a?
Oh, the days? Oh. Yeah, so this is the first day about it. These data?
Well, they're the group that also harvested the wrong leaf.
Yeah.
Oh.
It's either one group and here's going to have one missing, or one group Thursday is going to have one missing. Which would probably happen anyway because most of them are grass species and there's going to be nothing for them to record it.
Yeah, and I think some group thought they couldn't find them, and it turns out what they thought was like 2 was actually.
Yeah.
Did you all have questions?
Yeah. Well, the question is, what date did you write down here? The date that you weighed it, or the date that you extracted it?
So our first leaf.
And we can probably tell.
So again, how are you?
Because usually some people write down one.
Our first
I'm gonna be real excited when April's over.
So yeah, so we'll kind of have to, especially go ahead and calculate it, because you know, if it's wrong by 7 days.
This is our first one.
Well, yeah. Because you're going from all math.
Oh, in that one, because that's, and you're only gonna put the DK coefficient.
For the math.
So you'll need that, but you're not gonna.
Putting it
Well, our percent math for oh, was it great?
Like you're saying,
Okay,
one
Yeah.
so are we two?
Oh, yeah, the fact that you're going from 42 to 26.
Yeah, but we're gonna take the natural 100%. Because I didn't draw it.
No, I love Concord too, but the Concord game is always recategorized.
Yes.
I'll bring you back.
So for you can choose. So on the y-axis, you'll plot the natural You guys have your days out. Yes, so when you have.
I mean, I've studied like
Calculator to take it over this morning. I know. I think we're drawing out this week's lectures. Yeah, that sounds like so much So what do you? Well, not for art. Well, I was just gonna say, are these days the same? I don't know. Yeah.
Instead of, it helps you out every once in a while. Yeah, I got
Questions up here? Oh, you did.
You have the 56 max crossed on.
Oh.
It doesn't actually go down.
Oh, okay, gotcha. Oh, I see, those two were, yeah, okay, perfect. And you did, yeah, 28, 26, and these were the dates they were harvested, not the dates that were
Not the days it-
Actually, I had it written all so I
reference that. Okay, yeah, that's the same.
I got my numbers.
They have 28, 56, and 70. I did my mental math wrong, yeah. Okay, just double check it, because if we can come to an agreement, great, and if not, then we need to have a conversation about it. Because I don't know if, why should I just have this one, or like a week later or something like that, Well, it's not normal, but it seems like this semester, that's how it's going.
Yeah, I remember.
What do you do all this?
So that just, it kind of makes the line. I just like counted weeks. And so you can just do that with, there's a function, it's like just do equals LN, because the number of weeks doesn't.
Yeah, how do you find it?
So the K, we're gonna do it in a second.
Oh, okay.
Do you have your days already?
No, what do I need to put in?
So you need the,
Just this.
you'll need to have, oh, you mean in the group sheet?
No, in our file.
So you're gonna have time, the number of days each leaf was in the soil, and then the percent master rate. So just do those two things for now. We'll do the.
Is our second time for everybody 56?
I think so.
Because I did
Unless you were like.
I did record our day.
Not.
Yeah, I'm gonna put 57. Sounds promising.
Just trust.
Parentheses, percent MR, and then the number is 4.605.
You guys have the number of days calculated yet? Okay.
I can't do it, it's right there.
Is this your first one? That one was your latest one? Okay, we can talk about this, we might have you remove that one. Calculate your case. Yeah.
They've got some weird data.
Well, we'll look at it when we get in there, so.
Yeah, we got 47, 57, 47.
Oh. I like 42 better.
47, 42, 47.
So I guess it doesn't really matter, right? Like your first and your third are the same, so. Okay, we'll look at it and we'll try to explain it. Or we will.
Why did he start?
Okay. We have 100 days.
Yeah. That's not it.
I don't know, cause from here to here to here. Here's what happened.
But this was our first.
Wait, what did you have right here?
We'll probably do that last.
We did 100, you must have done 100
We might
minus
just end up moving that.
Yeah, right.
Or, oh, but for the percent, for,
Like that.
wait,
And
actually, did
so
you
then-
subtract
Oh,
100, that's the
yeah.
percent loss.
That seems pretty
That's the
normal.
percent.
Almost everybody's first two leaves were either almost the same or the second.
Ah.
I don't know how it happened that way. It's
So it is-
I feel like that needs to be a class
It is what it
announcement.
is.
Yeah, for sure.
I would call, before you start solving, I would call.
Is that, did you calculate that from, let's look at calculation.
Oh, yeah,
Because
we're
you
all right.
calculated that after you
She's
added
actually pretty
the
sure.
water.
I will say. She's.
Don't spike your ball.
So this is your weight before you add water. So.
I've looked back on the track, couple steps before the finish line, not commentary. Don't celebrate too soon.
Oh, I see. So this was supposed to be the weight of your pot before you added water. Yeah, okay, so you can track it. So if you subtract this from that, and whatever value, use that to calculate that.
Okay.
Right? And then we should have something less than something. This is the nice thing about recording a bunch of data, right? It seems kind of redundant.
Yeah.
We got one for you.
Okay.
So, when we do our calculations such as this, we get percent change. So we're doing original weight minus new weight divided by original weight. So we're getting percent change. Then do we subtract that percent change by 100 to get percent change? Or is it this one?
No, you should just do your second weight divided by your original weight.
So it's like a total.
And that's your percent measure.
Oh, so we were, okay.
You were making
We were
it,
making it.
you were making it fancy.
We did percent change, not.
Yeah. All right, I'll give you a couple more minutes to make sure you've got the number of days each leaf was in the soil calculated. Because I want to do an example calculation and we need that data to do it. So focus on that for the next couple of minutes if you haven't got that done. And then I'll go over some calculations with you. I guess you don't have to read that one off to me. So 86.75 was your first leaf. What about your second?
I think it might actually be 77. Yeah, it may also be its own calculation. Let me quickly double check. 75.7.
Thank you.
Open up my exam from 2.5 years ago. Good might be a stretch. Good.
The coefficient is just the light slope down.
Yep.
Okay.
We had our second one was not our first.
I think what I would do in that case is when you create these figures, go ahead and show that data point so you can talk about it. But in the K coefficient you put in the Excel sheet or the Google sheet, remove that point. Okay, let's go ahead and talk through this, even if you don't quite have the number of days calculated. What I'm going to walk through is just how we go ahead and calculate that decay coefficient, because we need to do that to add that to that Google sheet, that K value, all right, or your decomposition rate. So we've got 4 data points. We've got day 0. Hopefully all of you got day 28, 56, and 78 for the number of days those leaves were in the soil. But let's talk about that if you get something else and make sure we come to an agreement on how many days they were actually in the soil. Did somebody else calculate it and get different values? We all got the same values?
I got 77 for a while.
Okay, so you were close. You got 77.
Number of weeks, and it was like 3 weeks, so that'd be 21 days, so it would only be 77 as well.
Okay, so that one should be 77. Do you want to double check the calculation and see if we all agree on that? I'm happy if we're only off by a day. We're usually off by a week somewhere. So usually it gets calculated as the date you dried it versus the date you harvested it sometimes. So well, I'll go ahead and do the calculation this way, and then we'll make sure we come to some agreement on number of days. But let's pretend for now this is the right days. So we've got 4 data points. We've got our percent mass remaining. So you can see the first one, of course, we had 100% mass remaining. And for this aspen leaf that was grown at high relative water content and ambient temperature, that 56% of that leaf or mass was remaining after 28 days. Hardly any more was decomposed at 56 days, so it was 55 days. And then 42% at 78 days. So the next thing we need to do is we're going to calculate the natural log of the percent mass remaining. And the reason why is if we just plot the raw percent mass remaining, what we get is, or what we should get if our data is perfect, which it never is that we'll get a nonlinear relationship. There's this curvilinear portion of the curve. And this happens because decomposition rate slows down over time, because at first all the nice juicy easy stuff for the microbes to break down, that's what the microbes start on. So we see this real fast drop in percent mass remaining. But then there's less of that juicy stuff left over, and so now then the microbes have to start breaking down some of those chemicals that are harder and harder to get, mainly like lignin. So we end up with just a lot of lignin at the end, and all of the cellulose and carbohydrates and all the other good stuff is gone. So that's why we get this nonlinear relationship. we could calculate a nonlinear slope of that. That's totally fine, but it involves more math, and we don't want to do math. So what we can do to kind of cheat the system is if we take the natural log of percent mass remaining, it tends to make this relationship more linear. All right. So we'll calculate the natural log of that. And then our data should be, sometimes it still looks a little curvilinear, but it's usually more linear. All right. So the way to do that is there's in both Google Sheets and Excel, the name of the function is the same. So you would just type in an equal sign, and then ln is the name of the function for natural log. And then in parentheses, you just put whatever cell you want to calculate the natural log of. So I'm just going to click on the cell that has the 100 in it and hit enter, and it automatically fills it for me. Oh, I don't use Google Sheets, so.
Go down towards the corner.
Yeah, I'm just going to do it the slow way. So your values should end up being, in the 4s to upper 3s. So if you get numbers in that range, then you've done everything right, and you're probably in good shape.
77 is the correct number.
Okay, so you got 77. All right, we agree that 77 is the number of days for that last time point. So these should be the time in days of your data, unless you were absent a week and harvested your leaf a week later. And I don't know if that applies to anybody in here, but hopefully you know that. Okay, so we've got the natural log of percent mass remaining. Now we need to calculate the slope of this relationship. And there's a couple different ways you can do it. Maybe the easiest way is there's a function called slope. So in either Google Sheet or Excel, you can just type an equal sign, the word slope, put an opening parentheses, and it's going to ask for the y values first and then the x values. I don't know why. If I would have written this code, I would have put x values first, but whatever. So our y values are the natural log of the percent mass remaining. So we're going to highlight those. Oops. And then a comma to separate the y from our x values. And our x values are just the time in days. So I'm going to highlight those 4 values, put a closing parentheses, and then I get a negative value. Let's get rid of that. I don't want that stuff. So this negative 0.01 is the decomposition rate of an aspen leaf grown at 70% relative water content, ambient temperature. Okay? So hopefully if you did that, you got some negative value. They typically vary between minus 0.004 to minus 0.02, I think sometimes we've seen. So they can be an order of magnitude smaller than this for sure, and a bit bigger than that. But that's on the pretty fast end of decomposition rate. So just as a comparison, I have data for a ponderosa pine leaf that was grown at the same temperature and the same soil moisture. So I'm going to calculate the decomposition rate for the pondo and compare it to the aspen, and this will be a comparison of litter quality, right? So let's do that real quick. All right, so that's the decay rate or the decomposition rate for the aspen, minus 0.004 about versus minus 0.01. Is that going in the right direction from what we would expect? First of all, which one has higher litter quality, the aspen or the ponderosa pine? Do we think? The aspen should have higher litter quality. For a microbe, that's a good, that's good organic material. The pondo, I'm not going to be so excited if I'm a microbe when I see a pondo leaf. So pondo has lower litter quality. So does the decay rate or the decomposition rate of the ponderosa pine make sense relative to the aspen? It does. It's much less negative, the slope. So if we were to plot these, we'll say we have aspen in red. And so the slope of that line might look something like that. And our pondo would look like that. So much faster decomposition of the aspen than the pondo, which totally makes sense based on what we think we know or what we know about litter quality of those two species. All right. So this would be one figure. If you had, for you all, you guys can share data and actually, create this plot where it's the same environmental conditions but different species, so changes in litter quality. So that's figure 2 right there. Okay. Then figure 1, we would have the same species but different environmental conditions. So you're going to have to find another group that has the same species but different environmental conditions to do that one. All right. So go ahead and calculate your decomposition rate for your group, and then make sure to enter this value, that K value, into that Google Sheet, along with the other stuff that you've added there. Okay? Then, if you want to start, make sure to get somebody else's data before we leave today. And then if you want to start plotting up your figures and get those done before you go, we'll stick around and help you do that. But you can kind of decide from now on how far you want to get today, other than make sure you get data from another group today before you leave. Okay? Any questions? I feel like I'm probably forgetting to say something super important. Paula?
I just want to know the formula for the 4 points.
You probably can't see that, can you? Here, I'll write it. I'll write it up here.
Thank you.
Yeah.
Is that your data up there?
So in the parentheses, Paula, you would just put the cell number that has the data you want to calculate the natural log of. Yeah, exactly, which would be this one. Okay, any other questions? So this is due next week. Remember that if you weren't happy with your first lab report score, the score of this one can replace that score if you want it to. All right, so if you've kind of been working on your lab reports and we've been giving you feedback, and so if you feel like, okay, now I've got it, or I know what Troy and John and Jesse want, this lab report should be a really nice lab report. And so if you do well on this one, we can replace the score of your first one based on that. All right, so that is either motivation for you or motivation to not do it. I don't know. I'm just kidding. You should do it. But it might be some extra motivation to push hard on this one and make it really good.
Make sure you put in the comments that that's what you want to do, though. Because if you want to replace your first lab report and you don't tell us, we're not going to know.
Yeah.
Either next to your name or at the very bottom.
You don't take it better.
Nope. Well, you gotta opt in. You gotta opt in blind.
All right. Any questions for the group?
Okay.
Okay.
Roll those dice. You gotta roll them.
So go ahead and do the calculations. We'll be here helping you get the right data. And then you have access to this Google Sheet now. So once everybody gets their data in, you can take that and plot it up.
Along that line, the last lab report's only worth 40 points. The first one was worth 56. Do we just want to do it based on percentages?
Yeah.
Or
Yeah, we just do it on percentage.
Okay.
I should probably make this with this reasons.
Just quickly change it.
Yeah. So the first one was leaf size, color.
Yeah, that's the last.
Started for the slight bait and switch up to well, it was I mean, it was just because what I wanted to make sure that everybody had some comments coming in there too. We wanted to get your feeling. So I wanted to make sure everybody.
So if we actually have to get this number.
I go back and they can switch. Well, no, just to make sure that I'm being fair, because like I could be really nice at the beginning, and then like as I
Is anybody who has Ponderosa
if I'm
Pine,
ready to
30
the day or
relative water
end of the day,
content,
it
capital
can be,
T.
like the grades can change if I'm tired or something. So I go back again to make sure that everything is fairly. And then I also check
30 lower
like Jesse's grading to make sure if she's missing points that I don't have.
Aspen with 30 relative water content in lowercase t, anybody? Yeah?
Points off.
Wait, so we need the same relative, wait, we need to find someone with the same.
So you need someone with same species, but different soil so like different soil treatment. And then you need somebody with same soil treatment, but different species. So that way you can compare, because like the first thing was that their soil treatment. You need to hold at least one thing constant for each.
Is there just a document to find the other values that we're uploading, or should we go find something in class?
You can find something in class, there's the Google Sheet.
Oh, okay, so we can just use the Google Sheets.
You can, it'll probably be faster, or at least a little bit more easier to just find somebody. Because that way you know you can get the exact data copy. Because depending on how people are working through this sheet, they might start changing numbers and things might start being as like data analysis is occurring.
So, should we keep, for the same species, should we keep one of the values the same, or should we go for two different values?
You can either
Okay,
you
so-
can either go like full bore. I want ambient temperature and heated soil. If you were like 70% water content and heated,
so
you can go complete opposite, or you can just change one.
Okay.
That would just modify how you're talking about it in the discussion.
Right.
Because you could be like, oh, we held soil water content consistent, so that we could get a more accurate depiction of how temperature of the soil.
Sounds good, and then we should get one of the different species, same soil.
Yes, yeah. So that way you can assess the range.
Okay, cool, thanks.
Yeah, so.
Yeah, so you can either do both variables, in which case then in your discussion you'd be like, oh, we changed both soil water content and temperature, and this is where those like how they could interact. But if you keep at least one thing the same in your discussion, you'd be like, oh, we really wanted to focus on temperature or soil water content, so we kept this one variable consistent.
Probably easier to talk about.
Yeah.
It said it'd probably be easier to talk about if you just change
Yeah,
the variable.
it's definitely the smart one. But yeah, all that changes.
What's your variables?
Yeah, summer comes. No, don't worry, I'm awake. I'm sorry, I'm not enough.
Polar opposite of what we are.
I promise I'm awake.
Lowercase t. What are you? Uppercase t 30 for Ponderosa. Yeah, go for it. Just want our data off of here, or do you want just raw data? Any preference? Okay.
Yeah, I don't want to hand out any bad data.
Okay.
We already did.
But we did?
Yeah. But we have some funkiness going on.
Yeah.
On that last leaf.
Let's see. What did you had spruce 70T. I'm worried if we get rid of that last one, I feel like it's going to make it a really fast decomposition,
Right.
which might be unrealistic as well.
Right. Should I poke around to see what other spruce with the same 70 lowercase t have for
Yeah.
last?
See if we can find another one and see what they got.
All right. Cool.
Yeah, let's
I
do
can
that.
Thank you. Spruce? Anybody?
We can do maybe one same species. We can have one variable the same or none of the variables. So if I would, they have none of the variables the same. They are Here's this pictures of raw data.
Oh, for the slope, you're only gonna have one value, because you're using all four of those to calculate the slope, so then click on that first one.
Dry weight, or weight, yes, yeah. This number is consistent.
So this, yeah, that's the number, the other one's deleted. Because as you move it down, it's starting to incorporate empty cells. Because they give you numbers for those two. Oh, gotcha. Just like one. Yeah. And what did you, which one was your? We do 70. Is that how? Okay. And what's the acid? So dry. Okay, so much slower. So just the.
Yeah. Is that right?
Yeah.
Okay, you guys were. Okay. I mean, you've got this.
Okay, so this is wet and warm. Yeah, much faster evaluation than your dry.
Yeah, I'd ask if that's the.
It's going in the right direction.
I think that is the last, actually, now that you mention it.
So that's it's probably because I'm not having this.
So I found some.
Yeah, I think it's
Fine.
Okay, so yeah, for the.
Gotta love replication.
Okay.
So can you change that on the graph?
Hey, my man, we did some problem solving over there.
Yeah.
Yeah.
So this is first, second, third. Good.
So for the you guys got all the
That's much better, right?
Yeah, 47 was the first one harvested. First, second.
So this would be
Right?
different.
No, we're doing the similar tree going. If I like, yeah, we need to and once it's just like, oh yeah,
Yes, so that is. Both So yeah, so you can find Mondo set of average, you can find Mondo five.
Honestly. But we already got the difference. Basically.
Well, and you could also do because I see there's also Mondo. You can do both things. Like it'll take a lot. Yeah. So all it's gonna do is just change how you're talking about it.
Okay. How do we?
So there's, yeah, I would say go find it.
You all found the data you needed from the groups?
Yep. We just, it doesn't have to be like different on every level. Yeah.
No, no. In some ways, it's like kind of nice to only have one change, because then you can tie it to that thing, right? Whereas if temperature and moisture changes, you're like, well, I'm not sure which thing it
Yep.
was.
Yeah, that's perfect. That's what we got.
Okay, perfect.
So let's just take a look at our data. I think we're a little backwards here. Because to find the percent match remaining, we do the first value divided by, or the second value divided by the first value, correct? So we actually ended up, we had 47%, then up to about 70%. Kind of opposite what I would expect. Just go with it.
What I would do when you calculate, so for your scatter plots, for these, show all your data. You can also for your K value,
Average these.
just remove that one and use
Average these.
because 0 and 100%.
Okay.
Does that make sense?
Yeah.
If I was back to here, so if you entered all of your data here, before you calculated the slope, just delete that number right there. And it will calculate the slope. Then you should get a slightly more realistic answer.
Okay.
Otherwise,
size.
Yeah, you might not want to use ours. Ours is a little screwy. So.
What would you do that real quick? Do you calculate your key value? Yeah, exactly. Have it in your.
Here, I'll do it for you.
Because I didn't work in
Yeah.
and so it's like doing the LA. That's got a good different species, the same species. There we go. So use that for the key value of the report on. Yes. Without that.
What's yours, correct?
Because you had that, your first unit had really, like, was really low and then it back up. So.
Ian and Zach, you guys were Ponderosa 30 baked tea? Hey, I've got Ponderosa 30 baked tea right here. Okay, never mind.
But, so, do your scatter plots.
Hey, everybody.
Your data.
Can we have some data?
That on the top there?
That's yours?
That's our
So
good.
we sent you the data that we collected, but when we actually calculate the
Free data for everybody.
Right? Is that good?
Well, I've got it right here.
You guys all
Whoa, because it frees up that way. Yeah. Well, it's just because that might open up. Because right now, it looks like if everything was well, 30%, which might be well, like, I keep saying, like, I'm comfortable going by myself. I definitely don't want to because it's an 11 hour drive from 11 hours by myself. But, like, I could, it's only going to be for like 4 days. I definitely could do it by myself. I would much rather have
My dad decides not to. I've got 4 points.
Oh, I should write all this out. Jesse, right? With Nessie and Hudgens was the spruce?
Yes. Wait.
Well, 2 different symbols, 4 data
I think maybe I was still
Now I started writing them out.
Yeah.
If you give me a few guesses.
No, I can't remember.
Over there.
It's the one in the glass.
Okay.
Right behind.
Okay.
I'm looking
Thank you.
for something that's not Ponderosa uppercase and 30.
Oh.
Here's the scientific names for each species if you want to write those down. That's my best penmanship. That's as good as I get. So hopefully you can read that.
The zero one is the same.
We're taking photos.
Forgot my black. That's why it's still there.
Nice.
Yeah, it's actually been pretty consistent that I can forget an expo marker here in the States.
Oh, that's awesome. Everybody brings their own.
So when you're comparing two different data sets, you only want one change in variable. So
Yeah, that's surprising actually. I mean, I always think that in the room because I forget them, but I feel like most people are pretty careful about it.
Or you could do 7 capital T.
Yeah. Oh, okay, that works out well. I sent my and then, is that like a public document?
Everybody's just putting products in there.
Yeah.
Nice, then we've got it all.
Yeah.
But that'll be nice for the people on Thursday because they need participants. So glad yes.
Oh, they're all doing it on sheet 2?
Yeah.
We're going to compare. Yeah, like it's the same soil conditions for different species. So we're going to do
Oh, gotcha. Yeah, pretty much. Yep. And so you're gonna compare those two, right? Because those are the same environment but different litter policies. Yeah. So then you need to find out that's housing in different environments. Well, that's by season.
What's happening here?
You want Aspen. So you want Aspen 70 capital T or Aspen 30 something. Yeah, that would work.
Okay. I'll go change that.
So you want 4 lines?
No, just 2.
So we're comparing
So
That value is.
let's see.
or is it comparing our species?
Yes, same measures, and you only have to pick one other species.
And they're going to be similar.
Yeah, so here, yeah, that one's different. That's the same.
That's the time we look for Yeah.
So that one, does that one make sense? It's much drier than your conditions. And it has some slower. That one makes sense. No, it's about the same, because species is a litter flow. Oh, you're saying compared to that one?
What do we compare those?
You don't have to. Like, I'm not asking you to in any of the figures.
We'll figure it out. So we're just gonna talk about this. 3 sets of data. Our first one, our second figure is our data compared to different species with same sort of
Yeah, exactly. Yeah.
and that's the decomposition rate's gonna be the same.
Interesting. Exactly the same point. Pretty much, right? So in this case, and what was the average? Well, that's where you lose It might not differ very much. So maybe that's why. Yeah, get the other group temperature so that you can.
I don't think that is what I would
Because
consider.
just the way it is paintbrush, right?
Yeah.
Make sure for the other group's data that you got, make sure you get their temperature, their soil temperature, and relative water content data as well. So you can make sure you can use that in interpreting those figures. All right?
Yeah, sometimes the USDA gets it wrong. Apparently the USDA thinks Indian brush is a true factor.
Troy, how would you classify a functional group with castaway
Tree? Yeah, definitely one of classified as tree.
Yeah, I would say 4.
Yeah, I would have definitely said that. It's not even like it's
It's not even a substrate.
Right. You couldn't, I don't think you can make that argument.
Yeah, of course. Is that probably good for us to rating?
Okay. Yeah. And then you're just missing this data point?
Oh, so in that case, for hours, it went up, she was going down.
Okay, so we're just excluding it.
Yeah.
Okay.
Alright, so we're doing time versus
Oh no, but he was on those 2 species.
Okay.
Troy.
Yes.
Couple questions.
Yeah.
First, on the table that we put down, we just want those 2 species that we looked at. 'Cause it
For
says
the
both
table?
species. Yeah.
For the table, it should have all species, all treatments. Yep.
So yeah, in the instructions, it just says both species.
Oh, thank you. I knew there was something I probably didn't update, and I should have. I'll update that on Canvas.
Yeah, and it also says like 4 lines for the tables. Would it just be those 2?
I was thinking like the 4 species are each line, but then each one is divided, so I guess it's more like 16, right?
Well, I'm talking about on the graphs.
Oh, okay.
Yeah, yeah.
That was, I knew there was somewhere in there, I probably forgot, because
Yeah.
I used to have you put all 4 species on there, but then it's this graph that's hard to interpret sometimes, so I switched it to 2. So, just those 2. Okay, I just talked with Jessie, and she had an idea that might be useful. So here's what we're gonna do. This assignment is due next week, as is on Canvas. But what we'll do next week is we'll take a quick look at your reports if you want and give you a little feedback. And if you want, based on our feedback, if you want an extra week to make some changes, we'll let you do that. If after next week we look at it and we're like, hey, you did a great job, you can just be done with it and move on. All right, so that gives you a little extra time if you want to double check, like, is this figure right or did I have enough discussion? You can get some feedback on that and still make some adjustments, okay? So it's still due next week, but bring I need to change this right now. Bring a hard copy with you, okay? And I'm gonna change that on Canvas so it says bring a hard copy. Bring a hard copy with you so we can take a look at it. We'll give you a little bit of feedback next week, and then you can decide whether you want to put more effort into it or if you're happy with it and you're done. Okay? Sound good? Okay. I think that's it, except for changing canvas.
I know it's really hard to do this on the tablet. I like started to use my tablet at the beginning of the year. Yeah, I think these are too. Dang, I'm running tablets now.
Yeah, so that's an usual problem. That gap was. There you go.
That's one of the first ones, right?
Yes, yeah, this would be the first.
Where are you talking about on the original handout I gave you? It says that?
Yeah, that's these three.
Just today? Shoot, I think I must have printed off.
I can show you those.
Yeah, show me because I want to make sure.
Yeah, so right here, I've got like these two crossed out and then that crossed out.
Ah, okay. Thank you.
You're gonna add this data to this graph.
But the first one is just this one, right?
Oh, did you want to use another group with the same species?
Yeah, so she's got that. I could yeah, she's got population. Figure one would be these two, and then figure two would be these two. Does that make sense? Yeah, and then the fourth figure is that table.
So there's
Where
two
you have,
figures in
yeah,
one table.
yeah, you're gonna have two graphs, one table.
Oh, okay. It's not a.
Two graphs, one table. Yeah. Figure one is I got it. You should be able to. Yeah, you click add note.
I made one.
Okay.
Same time.
Yeah.
Where do you?
So now the problem is it's jumps. Well, no, it jumps your first data point to this one. It matched it to this third data point. Because there's like I just don't know how to do it on Google Sheets.
It's hard to tell.
Yeah. It's so nice and cheap and easy, but then it's like you only use Google. We have a computer laptop and like we only use for like watching TV.
then add a series.
Do you know anything about graphing in Google Sheets?
No.
Okay. So we'll all learn together. Because we added the second series in, but it jumped one of her time points forward.
Oh.
Because we're skipping one time point because it grew mass.
Yeah, right. What if you get rid of the 0 too in that row?
Well, so we added this second 0 because normally that cell was empty, but Google wasn't smart enough to read the empty cell as just something it should skip, so it was only plotting 2 points.
Gotcha.
So we had to move all of that down one cell.
Yeah. What if you're just to cut and paste those 2 rows up, so there was no missing row?
Yeah. Well, I think we run into the same problem. This series has a 28 data point, while the first series doesn't. So Google's going to keep, I think it's going to keep jumping this 3-point series forward one to try to match it.
So
Because
it's set as a scatter plot?
yeah, I've got it set as a scatter plot right now. So like it should be, as a scatter plot, it should be fine to.
Huh.
Yeah, I've got it set as a scatter chart.
That's really weird that it can't handle that.
Let's see. Okay, so line chart definitely doesn't work. Go back to star. We're just gonna delete everything.
Maybe we need to put Jenny.
Is the other session gonna put their data in for this as well?
Yep. Yeah.